Pretty crazy, huh? How it's where it started not all that long ago and where it is today. And if they said they had not developed that, and had not been commissioned, not started, where would we be, today? How many years would it have been before they developed something like that? Okay, nobody can really fathom what that would be like if the computer had not been invented when it was. So basically, as they said on there, computer is an electronic device that receives data, processes it, stores it, and then produces an output. So you have to have hardware, software, data, and people. So the actual machine itself, a bunch of wires and transistors and circuits, is called the hardware. The software is your instructions that controls it. And then the data can be in text and numbers and video or sound, images. Okay, so that's data. Then the computer receives the data through an input device, processes the data, and produces the output. And when the output comes out, okay, it's information, right? So data goes in, and then data can come out. And then it's up to the human and the software that the human devises to turn that into useful information. So special purpose computers that classify them control something else. Okay, so you have a lot of that in the electrical and electronics area, in the machining area, where some of my stuff back there, it's controls something. General purpose is like all the stuff that we use that's computer based. Okay, you see a list of them there. Everything from the supercomputers down to basically our phones. Okay, so we can use them for all kinds of tasks. Computers take raw data, change it into information. So we enter it, the computer uses instructions to process it, maybe do some other things that are pre-programmed, and then give some kind of output, whether it's to your screen, to a printer, to a three-dimensional printer, to a machine out here. And then we store that information or data for later retrieval. So your computer system has a processor, a memory, a sound card perhaps. Could be separate or embedded in the motherboard. Most of it nowadays, this is actually, this is a brand new book, but this is really an old computer by computer years. Everything is pretty much built into one card, or into one system like our iPhone. The modem card, the network card, all this stuff is integrated more and more into one motherboard, one circuit board. But you need these components, whether they're separate and you can change them out, create some kind of super gaming system or graphics system, or if it's a standard home computer, it's all built into one, and now they've got them, it just looks like a monitor. There is no box or anything, Of course, we got the tablet computers and the iPads. The motherboard is a circuit board that has all these components and different ways to connect. The central processing unit, we call it the brains. It has two sections, an arithmetic and logic unit and the control unit. A computer, I've always said, is just a box of switches, okay, or valves. And it can't count any higher than 1. It goes 0, 1, 0, 1, 0, 1. Several million times a second, okay, or billion times a second. The new computers, but that's all it can do. It can't count any higher than 1. It uses the binary on-off binary system, 0, 1. So that's all it does. Okay, and adds those up and takes in all your data and processes it So your logic unit, arithmetic logic unit, your ALU performs your computations and logical operations. That's what I was showing you here, the CPU. Then inside of it also is the control unit. And it coordinates, it's the director, it's the traffic master, and communicates with the computer through languages. All right? And as I said, it uses the binary code 1s and 0s. So recognizing how a computer represents data in a machine language, a control unit, I'm going to read this so I don't get it wrong. The control unit sends out necessary messages to execute instructions. A single 0 or a single 1 is a bit, and a byte is a single character. Okay, so there's 8 bits in a byte. Okay, I'm sorry. Yes. All right. So we have 8 bits. So a kilobyte is 1024, and we just call it 1000, approximated. But it's really 1024. Here's a terabyte, which now a lot of computer systems come with a terabyte storage, or half a terabyte. So it's 1 trillion characters. It's 1 trillion bytes. Okay? It's unbelievable what we have stored now. And I wrote this up here a while ago during the, I was reminded watching that on the ENIAC, the first time they ran the ENIAC, it processed enough information that what it processed, the calculations it did, everything that had been ever written down, all the information for the first 10,000 years of human life. Well, that's going back 10,000. It's kind of crazy. But anyway, they were trying to make a point. All the information up to that point in time was processed in just 90 hours by the ENIAC. Okay? And so our computers are like 1,000,000 times more powerful than the ENIAC. Then you have the memory where it's stored on the motherboard, okay? And that's in RAM, okay? Random access memory, okay? So it can be short or long. And then there's cache memory inside of there. Your secondary storage devices are like your hard drive and your USB. You can think of those as long-term. So your RAM is short-term. Data information are only there in the storage RAM while there's power. When it turns off, it all goes away. That's as if it truly turns completely off, not like if you put it to sleep. The instruction cycle is the amount of time it takes to retrieve instructions. So you'll see that listed as a specification on RAM, and the execution cycle refers to the amount of time it takes to execute it. Together, the instruction cycle and one or more execution cycles create the machine cycle. So all of that has to happen. Control unit, ALU, and memory. Okay, and like a standard computer, it's 2.4 gigahertz. That's how many cycles per second it's doing. 2.4 billion cycles a second. Okay, so it's really cranking, and it gets hot. So for every instruction, a processor repeats a set of 4 basic operations, which comprise a machine cycle: fetching, instruction, decoding, executing the process, and then storing it. So when we look at it as a chart, we can see the control unit, C equals A plus B. Okay, goes to the instruction decoded, what that means. The arithmetic is applied, 3 times 6 equals 18. Then the arithmetic logic unit executes it, and then the result is written into memory. Another type of memory is ROM, read-only memory. It stores specific, like computer instructions to make the computer run, and they're permanent instructions burned into the chip. It has a little battery power on it. Your motherboard or your your iPhone, iPad, or whatever with ROM in there, it has to have just a little trickle of energy to keep it running. So the basic input-output system, ROM, has those instructions in it.